Welcome to MCL Maths with Conceptual Learning. Today we will learn about functions. So today we will introduce functions and talk about functions, what are functions, and we will see the functions in mathematics and as well in real life. So when we consider the function outside the world of mathematics, we refer function as something does something. But in mathematics, word function has a more specific meaning. A function is basically something that relates or connects one set to another set in a particular way. So in mathematics, function is a value which converts into another value. If we see this diagram, we see that we put every input value into the function and it gives an output value.
In real life, you can relate as a function as a machine. As you can see in this picture, a function represents a machine that takes an input, applies a rule such as set of operations, and delivers in the form of an output. So in this picture, the input is in the form of grains and the output is in the form of chopped grains. We can take another real life example as hair dryer which takes electricity and converts into hot air. Electricity is in the form of input which we are providing to the hair dryer and output is in the form of hot air.
Mathematically, the function is written as y is equals to f of x, where x is an input and y is an output.
Input versus output. The input is the number you feed into the expression and the output is what you get after the lookup, work on calculations or performing calculations. So you can see in this diagram, we choose a particular value, we choose a particular function y equals 2x plus 3. We take a particular input x equals to 4. And after putting this input value to the function and applying some operations, we get a unique output y equals 11. So input is an object we put into the function, whereas output is the object that we get from the function. Let's look up at a detailed example. Consider the function f of x equals 3x negative 2. If you relate this f of x and you can write mathematically to the previous one, you can write it as y equals f of x. We choose particular values, input values, x equals to 5 and x equals negative 2. For this particular values of input, we get a unique output. Here is an exercise. Consider the function f of x equals 7 over 4x negative 1. By recalling our previous examples, I'm sure you are now confident enough to find the output for the following values.
Now, what is a set? The concept of sets is used for the foundation of various topics in mathematics. To learn sets, we often talk about the collection of objects such as a set of vowels, a set of negative numbers, a group of friends, a list of fruits, a bunch of keys, etc. The collection of well-defined distinct objects is known as a set. The word well-defined refers to a specific property which makes it easy to identify whether the given object belongs to the set or not. The word distinct means that the objects of a set must be all different. So in mathematics, we can see the different sets of real numbers, such as natural numbers, integers, rational numbers, irrational numbers, and the set of the real numbers is the set of numbers that includes all the sets described above. Any natural numbers, integers, rational or irrational number is a real number.
Let's look at an exercise. State what each of the following numbers belongs in. You can relate to the previous definitions of sets. You can find that which numbers belongs to the set. Domain and range. As you can see in this picture, we have given two graphs. The set is the first picture describes in the blue line, which is the set of all possible x values of the function or x-axis of the function. So this blue line represents the domain of the function, which is the set of all possible input values of the function. In the second side of the graph, you can see a red line, which represents a vertical axis. So the range is the set of all possible y values or output values of the function.
Mappings. Mapping basically is a concept, another concept of a function, and it's a type of a relationship. So in this relation, each element of the domain is paired with exactly one element in the range. A mapping shows how the elements are paired. It's like a flowchart for a function, showing the input and output values. A mapping diagram consists of two parallel columns. So one column we named as domain and second column we named as range.
Consider the function f of x equals 5x plus 9. We choose a certain input values. X equals -4, x equals -1, x equals 4, x equals 9, and x equals 12. You can see that here for these input values, we get a unique output values. So we can associate a mapping like this. Here, each input value maps to a unique output value. You can see here -4 maps to -11, -1 maps to 4, 4 maps to 29, and so on. In the left hand side, you can see here, these are all the set of input values contained in a domain. And the right hand side, you can see here, these are all set of output values contained in a range. The mapping for this function can be seen as each input value maps to a unique output value like this. So this function relates or describes a mapping. We cannot have a mapping like this. We choose a particular input values and map to any output values. Input value of 0 maps to the output values -1 and 114. As one input value maps to more than one output values, So that is the reason the mapping is not a function, because it contradicts the definition of a function. Here is an exercise. Determine whether each mapping is a function. State the domain and range. Here you are given two mappings, and you have to find first each mapping is a function or not, and the second you have to find the domain and range. Now, by relating to the previous examples and definitions, I am confident enough that you can do.